first. So red-black trees, some key properties of them are that each node is red or black, and all of the root and leaves are black. And what it means when a node is red is that it has two black nodes as children. And in order to find like the height of the tree, you can remember that every leaf has the same number of black ancestors. And then a specific type of red-black tree is a left-leaning red-black tree. This is when a red node can only be the left child of its parent. And then there is a one-to-one mapping between left-leaning red-black trees and 2-3 trees. So as an example, we have this left-leaning red-black tree, and it can be also drawn as its equivalent version of a 2-3 tree. And then when we're inserting a node into an LLRB, we always insert it as red, and then we perform rotations and flips to make sure that it's balanced and it follows the properties of an LLRB. So can talk about the rotations. So if you have a right-leaning red node, what you want to do is rotate left on its parent. And so you would, in this example, you would rotate left on A, and then I kind of drew out a sub-step of what happens. You can kind of think of A and C as like temporarily joining and then draw out where its children are, and then that would make it easier for the next step when A will now move over to the left side, and it'll contain the children B and D. And then if you have two consecutive left-leaning red nodes, you want to right rotate the tree at the first one's parent. So in this example, you would rotate right at A, and then again, you can also draw it as having this sub-step where you connect B and A to see where you want to keep the children. And then in this case, you would have B be at the root, and then D and A would be its children. And then the last official operation is when we color flip a vertex. So if both children of a vertex are red, we want to color flip that vertex. And this is just when you switch the colors of the parents and children. And then like a kind of like a sub-step of this is coloring the root black. So if a root is red, then we can color it black. And then we'll, after performing all of these operations, after you insert a node into the tree, you'll have a balanced LLRB. So we can go start the example or the question. So draw out the left-leaning red-black tree resulting from inserting the following 35, 11, 49, 9, 7, 51, and 50. And it says to draw red nodes as boxes instead of circles. Okay, so we can start by inserting 35. And remember, we always want to insert it as red, but since in this case, 35 is our root node, we can color it black. So then we have, so now we want to insert 11, and we want to insert it as red and as a leaf. Okay, we still satisfy the properties of the LLRB. So Now we want to insert 49. Okay, and now we have a right-leaning red node, and also a node where two children are red. So we can perform color flip on 35. This says red for now, and then we can actually color the root block since 35 is the root. Okay, so now we insert 9. Okay, and then now we insert 7. So now we have another violation. We have 2 consecutive left-leaning red nodes. So if we see what we should do, we want to rotate right on the parent. So we can go. We want to rotate right on 11. Okay. So can also draw out the sub-step for this question. So we can have 35 here, and then we're kind of doing a sub-step here to make sure that the children go to the right node. And then after this sub-step, we would have we would rotate right. So we would have the tree looking like this. And then this node would stay red. Okay, so that's after inserting 7. So the next step is to insert 51. Okay. So we would insert it as a leaf, and then we have another right-leaning red node. So we want to rotate left on the parent. So rotate left on 49. And then I'll just draw the other part. It should actually be a square. So to rotate left, then we can do our sub step first. So 49 and 51. And then that would be, we would put 51 as the parent, and then 49 as the child. And then just copy the other side. Okay. So last step is to insert 50. So remember, we insert it as a leaf. So we can insert 50 as red. And we have another another violation, we have a right-leaning left node. So we would want to, rotate left on 49. So the sub-step, we can do 40, 49, 50. And then we can draw the completed subset. So let me just draw this side of the tree first. So now we would have 50 as red and 49 as red. So now we have another violation. We have two left-leaning red nodes. So we can still do, I'll put it here. We can do rotate right on the parent. So rotate right on 51. And we can also do the sub-step after drawing it out. And then after the sub-step, we will have 50 be at the parent, and then 49 and 51 be its children. And then 50 be red. Okay, and then now we have another violation. We have two red nodes as children for 35. So we can color flip 35. And then since 35 is our root, we can actually color the root black. Which is basically we're doing the color flip operation. Okay, and then after we draw this out, we have our finished balanced left-leaning red block tree. And yeah, so that was question 3 on the worksheet.